Hello everybody, in today's video we're going to be discussing the winter and fall pattern. We're going to briefly or generally be discussing from October through April, which is generally when we're dealing with the majority of our snowfall across the United States. Yesterday we talked about more broadly what a La Niña means for the United States and also parts of Canada, but now we're going to be talking about what some of the models are showing for this winter season. I would highly recommend that you go check out yesterday's video. By the way, if you have a comment or a question, just leave a comment down below. I'll be responding within a few hours of you posting that, and as soon as I can. If you want a personal forecast for this winter or for just any random storm that may be coming across your area, just leave a comment down below, and again, I'll be more than happy to respond with a forecast for your area. So again, I'll be answering pretty much all the comments, and if you have any questions, just leave a comment down below. And also my email is also in the description, so if you have any personal inquiries that you want to send down there, you can put them in there as well. So right before we get into it, just want to say that we are having an upload schedule change. So for the past couple of months, of course, I was on summer break, so I had the mornings where I could do the videos, and then of course I went to my friend's house in the afternoon, or we just played games or did pretty much whatever in the afternoon. So I had the morning time to do whatever summer work I had, or also to do the videos. And now that's going to be shifting to the afternoon, of course, because I'm going to be at school. So today, this video is probably gonna be uploaded. I'm right now recording around 3:20, so I would assume this should be up by around 4 p.m. Eastern time. But for most days, we're looking at 4 to 6 p.m. Eastern time, 3 to 5 Central time, 2 to 4 Mountain time, 1 to 3 Pacific time. So again, it's gonna vary from day to day. One day I might have a lot to do, so it might be around 6 or 7. I don't think there will be too many days where I'll have to push it that far back. But for the majority of these days, I think it's going to be 4 o'clock, maybe 5 o'clock, 6 o'clock Eastern time. And that's really going to depend on how many graphics I need to put. So if there's a winter storm and I need to put out my snowfall forecast, maybe that video might be uploaded around 5:30 instead of the 4 o'clock upload, which I might need for if we're just talking about the pattern and I only have to make the thumbnail graphic. So it's going to all vary. It's all very dependent on how many different images I need to put into the slideshow in the frame, how many different graphics I need to hand make. So again, that's all dependent on that, and this is only for Monday through Friday where there's no holidays. So if there's any holidays, any weekends, I'll probably go back to the morning uploads for those days. So this is only mainly for the days when I'll be at school during the week. So here's the upload schedule change. I might have this in the next couple of videos as well, just so that I kind of get the message across to everyone who watches the videos regularly. Here's a look at what we're looking at right now in terms of the ENSO pattern. If you're not familiar with the ENSO, if you're not familiar with the terms like La Niña or El Nino, basically what they are is a snapshot of the sea surface temperatures for this area of the Pacific. So that's the area just off of South America. When you have warmer temperatures, which would be indicated by orange and red colors over that area, that's typically indicated by an El Nino. So that would be one of the warmer winters for especially the United States. It might be a little bit colder actually in the West. So again, these are all going to have different impacts on the United States. ENSO neutral is a term you may have heard, and that's when usually we have neutral temperatures within that area, and that can cause normally a fairly cold winter for the eastern and central United States. And same thing for a La Nina, where you have colder temperatures within that part of the Pacific. Normally you have a fairly cold pattern, especially for the northern half of the U.S., and then the southern half of the U.S. Tends to be a little bit drier and warmer. So that's just kind of a brief summation of the ENSO, just for anybody who doesn't know about that. Again, yesterday's video, we talked a lot more about what a typical La Nina would show, so I would recommend you go over onto my channel and search for that video. It's the most recent one before this. So again, watch that one. Definitely a great video to watch if you want to learn more about a La Nina, because we're not going to spend too much time on that. We're going to mostly go onto what the models are showing and showing you some of those predictions from that. If we look again, just a quick chart of what a La Nina typically does, you have a high pressure somewhere over the Gulf of Alaska. If this is a little bit further to the east, then the cold air will also be further to the east. If this is further to the west, which normally it's not that far to the west, but if it is, then you would probably be dealing with the cold air also moving further to the west. So it's all dependent on the high pressure out near Alaska way more than anything else, and that's going to drive the jet stream because the jet stream is going to dip down so far to the south during the winter. You're going to have those colder temperatures which are going to fill up for this entire area right here. So this entire region is typically going to be a little bit colder than normal. And you can see that to the south of there, you're not going to be as cold. So you're going to have warmer conditions, drier conditions for the southeast, the southern plains, the southwest. But that is not in all years. There are definitely some La Ninas where that high pressure up near Alaska is so far to the north. It's actually in parts of Alaska. It's over central Alaska. And that makes that jet stream move all the way up. And it's going to have to go all the way down as well. So there are some winters where the southern plains get in on some of the really cold temperatures, and I'm going to show you a chart of that in just a moment, which will show you some examples of that happening. If we look at the probabilistic forecast for this, you can see that up until the April time frame, so we'll go from October to April, which is normally how I would classify that winter time, because starting in October, I'm usually actually right now I'm starting to actually look at the models, just briefly scanning through most of them to see if there's any snowstorms or snow events that I need to kind of keep my eye on, especially if it's in the northern plains or the Midwest, because that's normally where they first start up, or also up into southeastern Canada and also into New England. So I'm just checking briefly every day pretty much to see if there's any snowfall up in there. And I usually, again, I'm not doing that in August, July, June really, because it's too warm. But I think as you get into the later half of September and October is when you really start to get more into that winter time frame, and snow starts to become more and more of a discussion. So I like to think of winter as October to April, especially because in the United States, especially in parts of, let's say, the northern plains or parts of northern New England, snow is still going on through late March and April, and it can start as early as October. And it's even crazier than that in the Rockies, where you're dealing with snow in September and ending in June. So that's how I like to think of winter, and so that's the time frame I'm going to use. You can see a La Nina is definitely more likely within that time frame, and especially from November all the way to, I would say, February, you're looking at 70 or 80% chance of a La Nina within that time frame. If we look at the model average of that, you can see that that is also dipping fairly far below the La Nina threshold of minus 0.5 degrees below normal. So we're looking at a fairly solid La Nina, but it looks like it'll be a weak La Nina, and that would mean that the cold air would be a little bit more broad. It wouldn't be as concentrated, so therefore it would spread off a little bit further to the east than what we would see normally in a moderate or a strong La Nina. If we look at the numerical predictions for this, you can see in percent chances. So, for example, this is a 78% chance and a 32% chance. You can see that we have, again, using that example, from October, November, December, that 3-month time frame, you have a 78% chance of seeing a weak La Nina and a 32% chance of a moderate La Nina. So that's kind of how to read this graph. You want to pay attention to these two columns right here and within this box. So this is where we mainly want to pay attention to. For that October to January time frame, you're looking at around 78, 79, 80% chance of seeing a weak La Nina. The moderate La Nina chances are going to go up a little bit towards the middle of winter, or actually the beginning. So we're looking at November, December, January with the highest chances of seeing a moderate La Nina, and then they're going to go back down to back down to right around a 60% chance, 48% chance. And the reason that's happening is because now we're having the possibility a little bit more that you'll see a neutral ENSO, where you're going to have temperatures that are going to be right around normal. And I think that's more likely as you get into March, April, and May than it is for any of the winter months or the solid winter months. So That's going to be something that you want to pay attention to, of course, and I think it'll probably turn a little bit warmer into spring for much of the country. So you're going to need to get your snowfall in early, probably for December, January, February, the traditional 3 winter months. I don't think there will be too much wiggle room. I don't think you're going to see any huge March storms. It's definitely possible. I don't think we're going to see a huge train of March storms, to say maybe not 2 or 3 big snowstorms in a row. It looks like March is going to be a little bit more tranquil after what looks to be or may be a fairly hectic winter. If we look at some of the past times that we've seen a weak La Nina, which would cover anywhere below this black line right here, you can see that with the notable exception of 05, 06, 2011, 2012, 71, 72, and 74, 75. So we're looking at 4 outliers after over the, I would say, what is that? 10 the 10 different images right here. There's 4 outliers that they show up here, but there are definitely, I think, a much better chance that you're going to be not within that outlier category. So if you're looking at for the majority of non-outlier years for La Niñas, weak La Niñas, you're looking at 08, 09, where you had cold temperatures for that northern tier of the U.S., 95, 96, broadly cold over the eastern and central United States, 54, 55, a little bit different, where it was just generally cold over the entire United States, but still that area of the west, northern plains, eastern United States, fairly cold. If we look at 71, 72, fairly traditional, almost a moderate La Nina look for that time frame. 2000, 2001, we're looking at, again, a big trough into the east. 64, 65, looking at cold, especially for the northern plains. 83, 84, we had what happened with Alaska, where you have that ridge going all the way up into central Alaska, and that means that your trough is going to go way down to Texas or even Mexico at times. So they were really cold for that year. And then, of course, we have the outlier year of 74, 75. So that's just a few examples. And again, these are not all of the examples of La Niñas, but it's just a few of them that you want to look at, because you want to have references. Again, we would not know a lot about the weather or climatic forecasts if it were not for previous events. If we were just looking at this with no understanding or knowledge of what happened in previous La Niñas, then this would probably not give us too much information. We would mainly be going off of what model predictions are showing and not really looking at past forecasts. And again, usually you want to learn from your past. You don't want to kind of try and reinvent the wheel, or you really don't want to only look at what's happening with some models, which I think a lot of people do, especially in the winter, where they only look at models and they don't look at past events. And past events are really important to look at when you're looking at the weather, because you can get a good feeling for what may happen. There's some winters where there's certain type of storms that always happen. For example, just using as an example, you may notice that in some storms for a particular winter, parts of the lower Ohio Valley may get an underwhelming amount of snowfall compared to what they're expecting, and that happened 2 or 3 times in that same winter. Well, now for the third or fourth time that we're expecting a snowstorm to bring 6, 7, 8 inches for that area, now I'm gonna bring that snowfall total down to maybe 3 or 4 inches, because I know that during this winter, for whatever reason it may be, there has been an underwhelming amount of snowfall for that area. You always want to go based off past events, and it can really help not only with the long range, which is what we're looking at now, but also in the short to medium term. And I think a lot of people just look at models. They just look at, oh, it's going to snow here, it's going to snow there, and according to the GFS and the European model, when that's not really the most important thing. You want to understand why the weather is happening. You also want to understand trends within the weather pattern. If you look at some of the model predictions here, and again, these are the model predictions that go way out, so they go months and months out, and this is an average, so I trust this way more than if I was just looking at 1 or 2 models. But the average of almost 50 models here, we're right here, is showing that we're right around half a degree below normal, so that would put you into the La Nina territory. If we're looking at the breakdown of this, you have statistical models on the top, dynamical models on the bottom left, and then all of them combined on the bottom right. We have dynamical models. That includes your UK Met models, your European model, the Australian model, the French model, all of the European models, and also some parts of Oceania, the areas like Australia, New Zealand, where they produce some of the models. That's going to include their models. And then the more statistical models, that's more of the GFS type of models, more of the North American models and South America models as well. So they use two completely different types of methods to find out what's going to happen, and that's how you kind of sort them. Dynamical models typically are looked at as being more reliable, and if we look at the dynamical models, which I like to trust a little bit more, you're looking at probably a weak La Nina according to most of these. Now there's a lot of them, so it's hard to see, but the trend of them would show most of it being below that half a degree line, which would be below the ENSO neutral line, meaning that you're in a La Nina. If we look at the model-based predictions and kind of look at the distribution, again, this is going to show you that we're really hugging that line between a neutral and a La Nina. So this is your neutral line generally, just kind of an estimation. And you're looking at about half of them being below there and half of them being above there. So maybe there's some classification difference where it ends up being classified as a neutral or a weak La Nina. It's not going to really matter. It looks like even if it is technically an ENSO neutral, it'll probably still have similar effects to what we see from many La Ninas. If we look at, again, that model-based prediction and look at the individual squiggly lines there, or kind of the spaghetti lines, whatever you want to call them, you can see that the majority of them, and again, it's hard to see, but the majority of them are going to be below that threshold for seeing La Nina. But again, it's by a thin margin. You're going to see that this is going to be a tight winter in terms of the ENSO. It's going to be really close between neutral and La Nina. Again, I don't think it's going to really matter, since you're still going to have similar impacts either way, either side of that neutral or La Nina token. If you look at now some of the models, and again, I know I was saying don't look at the models, I mean mostly for shorter range situations. We already looked at some of the past events, and again, I usually don't look at some of these models on the surface, and I think the surface is where a lot of people get mixed up. They look at the temperature anomalies on the 2-meter temperature anomalies, and that's the most popular. If you ever see a model forecast being shared all over social media and it shows the really cold temperatures, probably they're looking at these 2-meter surface temperatures, and very rarely are you going to see, for most social media accounts, the upper air maps. Now, there are some very good people, some very good meteorologists out there which do use this, and I think it's the most reliable because the upper air is not going to change nearly as much as what you'll see on the surface. And this has not changed quite a bit over the past 2 months. It's changed narrowly, and that's actually gotten a little bit colder for the eastern U.S., but it's not changed a lot. And if you were to look at the 2-meter temperature map of this, that has changed back and forth widely, but not this. So you want to, when you're looking at models, if you are going to look at models, which I recommend, I think you need to look at models, mix that in with past events, but if you are, you always want to look at the upper air maps, not necessarily the surface analysis maps. I like to save the surface maps to within 5 days of an event. So if you're seeing the snowfall total maps already being posted all over the place for some snow event in, let's say, Montana, Idaho, or Wyoming, you don't want to pay attention to that if that's happening 15 days from now. You want to pay attention to that if it's happening 5 days from now, because that's going to be a lot more accurate. And that's what we're doing here. We're looking at the climate forecast in the upper air. If you look at the upper air maps, these are going to be way more accurate, and they'll tell you a lot more information. So for November, you can see that we're expecting a little bit more of a colder pattern into the northwest and the northern plains. So a little bit chillier there, not necessarily warmer for the East Coast, but probably a little bit near normal. And then for the Southeast, the Southern Plains, and the Southwest, you're probably going to be on the warmer side of things. Starting in December, it starts to turn. So we only get the 1 month snapshot. If I had to make a guess, or I guess you could call it a forecast, I think this turn in the weather is going to happen in late November and not necessarily in December like what it's showing, just because we only get the 1 month snapshot. So if this is taken on the first day of every single month, then we're looking at November 1st to December 1st. That's a big hole and a big gap right there. So in order to fail that, you kind of have to do a little bit of mental gymnastics. And doing that, you can figure out that probably sometime after the 15th of November is when it'll probably start to get a little bit colder for the east. So now parts of the west and the central United States for December, and only for December, will probably get a little bit of a break from the cold, and it'll probably turn warmer as for parts of the northeast, the mid-Atlantic, and generally down the southeast coast as well. It'll probably turn a little bit colder for this time frame. And it is a sharp kind of a little trough right here, which goes from, I would say, the middle of Michigan all the way down into parts of the Atlantic coast, and then it moves back up into Nova Scotia. So this is a deep and sharp trough into parts of the East Coast, and then it's going to moderate out into January. So January, I think, will be a cold month as well, and it's for this reason. You can see that we have a general area of troughing into the eastern United States. I think this is, if you are going to get a snowstorm in the southeast or the southern plains, probably it's going to happen in late December or going into January, because that's probably going to be when it's coldest. And the colder it is, that means the further down that 32-degree Fahrenheit line is going to be. And of course, you need 32-degree or lower temperatures, or generally could be 34, 35 degrees to snow, but generally you want to be below freezing to see snowfall. And you're going to need that line to get fairly far to the south. So in a couple of these cold snaps, if that can mix up with a little bit of precipitation, I know there's a lot of people down in Georgia, South Carolina, Alabama who have been asking me, am I going to get snowfall? And it's a tricky question to answer. But if you are going to get snowfall, it's going to happen in one of these quick cold snaps. It probably will be a less expected storm. I'm not expecting that we're going to have 10 days, 5 days notice of that snowstorm, because these type of storms usually are very quick in forming and very quick in happening. So you're going to need to be attentive, and I would say especially for late December and early January is where I'm targeting for the potential for a really cold snap in that area. You can see that the CFS forecast, which has a warm bias, especially on the surface of this model, once you get into the upper air, that bias gets removed a little bit, which is why I like the upper air maps a little bit more. And you can see that has that trough for January well into the eastern United States, still warm for the west, and then you can see for February that it does get a little bit colder into those areas where you're still dealing with a fairly big trough into the eastern United States. It gets warmer into parts of the southeast, southern plains, and potentially a little bit chillier into parts of the interior mountain west. So potentially for this area, it could be a little bit chillier based on what we're seeing off this map. Now, again, that is going to wrap it up for today's video. I hope you guys did enjoy it. Again, here's the upload schedule. I'm not going to review it again, but just so it's on the maps, on the screen, so that you guys can see it for anybody who skipped ahead of the video. If you have any questions, leave a comment down below, and I'll be responding. If you want a personal forecast, also just leave a comment down below, and I'll be responding to you guys quickly, or as quickly as I can. And that is going to wrap it up for today's video. So hopefully you enjoyed it, and I'll see you guys in the next one. Goodbye.